Hi, I'm Jaemin from KAIST. In this video, I'll present our paper, MyDJ, Sensing Food Intakes with an Attachable on Your Eyeglass Frame. Food journaling is an effective method for maintaining healthy eating habits that brings awareness of the food intake and leads to a healthy choice of food. Despite the web or mobile apps that facilitate interactive food journaling, the manual effort involved in journaling often made users to lose habit in the long term. To address this issue, eating detection wearables in various form factors have been proposed to assist users in journaling. However, they typically show low accuracy at outside the lab environments, or are inappropriate to wear in social dining situations with their distinctive form factors. As a promising alternative approach, eating detection on eyeglasses recently emerged, as its close proximity to mouth provides an ideal condition to detect eating events. Moreover, the eyeglasses' familiar look and comfort with users makes it acceptable, unlike other wearables. However, existing approaches with eyeglasses require custom-built frames to accommodate various sensors. They required the eyeglasses to be built with specific materials or be tailor-made for each user. This results in reduced usability, as users mostly wear various non-instrumented eyeglasses. Moreover, some previous proposals with eyeglasses were energy inefficient or inaccurate in practical settings. We propose MyDJ, an attachable device that detects eating on any eyeglass frame. We designed MyDJ based on 4 design goals to mitigate the limitations of prior approaches. We designed MyDJ to provide robust and accurate eating detection on different users or environmental changes in the wild, while being energy efficient in its operation. We also designed MyDJ to be easily integrated with any existing eyeglass frames, while being comfortable to wear. We propose multimodal eating detection with 2 low-power sensors, an accelerometer, and a piezoelectric sensor, which enables power-efficient and accurate eating detection. For robust and accurate sensing in the wild, we designed each sensor to capture complementary chewing signals to enable the system working even when one type of signal is weak. We designed a piezoelectric sensor to capture the temporalis muscle contraction, which elevates the lower jaw on chewing. The sensor, placed on the inner side of the eyeglass frame, captures the huge mechanical dynamics on its skin when the muscle contraction happens. Moreover, we designed an accelerometer to capture the propagation of mechanical vibrations, which occurs by the crunched food and by clenching the teeth while chewing. These waves propagate onto the eyeglass frame via the locations near the nose and the ear, where the frame are in contact with the human skin. We place the sensor on the eyeglass temple to sense such signals. The graph here shows the sensor response when a user wears MyDJ attached eyeglasses and chew 5 times. We observed that each sensor shows sensor-specific patterns of peaks with chewing activity. This suggests that each sensor captures unique signals distinguished from the other, as we designed. We tested MyDJ on 4 activities and visualized the time and frequency responses of both sensors. We observed that eating is well distinguished on the piezoelectric sensor from other activities on both time and frequency domain, as well as on the accelerometer sensor. And now, let me introduce how MyDJ detects eating using the 2 sensors. Both sensors on MyDJ continuously generate raw data stream, which is further segmented into 3-second windows. From each window, MyDJ extracts features that further becomes an input data to the classification model. We used STFT and MFCCs for our features. As we designed MyDJ to detect eating on board, we further reduced the feature space by selecting minimal but optimal set of features with JMIM feature selection method. From the extracted features, we used a fully connected DNN classifier to determine if the user was eating at a 3-second window. To minimize the memory footprint of our model, we used only one hidden layer with 50 hidden nodes that consumes 10.61 kilobytes of memory. To evaluate MyDJ in the wild, we conducted two studies. First, we conducted a day-long data collection study where 24 participants wore MyDJ attached on one eyeglass frame for a day. We collected the ground truth with camera to precisely capture user behaviors. Our intuition of conducting a day-long study is to train a classifier to evaluate MyDJ at a longer duration. Thus, we conducted a week-long data collection study where participants wore MyDJ attached on their own eyeglass frame for a week. At this study, we collected more realistic and diverse user behavior without the camera. From the day-long study, we tested the eating detection performance on MyDJ on different number of selected features and compared it with single sensor scenarios. It shows that our multimodal sensing with MyDJ outperforms single sensor-based approaches in all cases. In our paper, we chose MyDJ to use 50 input features, which result in 98% accuracy, 0.92 F1 score, and moreover, MyDJ detected 92 out of 94 eating episodes from the day-long study. From the week-long study, MyDJ also showed high performance by achieving mean F1 score of 0.85 while being attached on the user's eyeglasses for a week. MyDJ also achieves power-efficient eating detection, that it achieves more than 4 times the battery life improvement over the state-of-the-art eating detection system on eyeglasses. Lastly, we asked questions on the usability of MyDJ, where MyDJ scored 95% compared to the regular eyeglasses on average. We further conducted both quantitative and qualitative analysis on the usability of MyDJ in the long term, which we present in detail in our paper. Here's a summary of our contributions. Please refer to our paper for more details and interesting discussions that we were not able to cover in this presentation. I'm happy to take any questions or have a chat on our project, so if you are interested, please send us an email or reach out for a discussion at the conference. Thank you.